Welcome to qnawire.
Alkenes have intermolecular forces called as London dispersion forces. So what is intermolecular force? This is a weak interaction force between the molecules present in the given solution. Okay, so normally alkanes are saturated and they are non-polar in nature. So the polarity is less. So normally the intermolecular forces are not that great in alkanes. So when the intermolecular forces are observed is when the chain length is big or when the pressure on the alkanes is more, which is forcefully make them to liquefy. Then they get induced dipole in between them and form weak interaction forces between them. So if the stronger the London dispersion force, higher will be the boiling point. Okay, for example, if you take methane, normally methane will be in the gaseous form. So you need to have a high pressure to condense methane. So as the chain length increases, the London dispersion force increases because the surface area increases. Okay, so let's take an example, that is N-pentane. So you have 5 carbon atoms with hydrogen atoms. Okay, so as the chain length increases compared to methane, you have lot of electrons here. So as the electrons are free to move, so one certain stage at one end you may contain lot of electrons and the other end may contain less electrons. Due to this, you have partial negative and partial positive charge on the molecule. So this which has partial negative and positive may induce dipole in other respective neighboring molecules. So like this, there will be a weak force of interaction, that is London dispersion forces between the N-pentane molecules. I hope you now know how the induced dipole is made. Then let's compare the different types of alkenes here. As the larger the carbon chain, have more surface area, so more the London dispersion force of interactions are observed. As I said earlier, so as chain length increases, surface area increases, electrons movement increases and the induced dipole also increases, so London dispersion force is also increased. So if alkanes contain, if you want to compare the same type of alkanes but have a different structural formula but same molecular formula, then we need to see the branching. Okay, for that you can take an example of N-pentane and other molecule. This is also pentane but it is branched. Okay, so if you compare these two 5 carbon alkenes, you can see the straight chain has higher boiling point or straight chain has higher London dispersion force compared to this molecule. Okay, the last point, that is rings have more London dispersion force of interactions than the straight chain counterparts. So for example, you can take cyclopentane and normal pentane. So normally cyclopentane have high London dispersion force compared to N-pentane. This is because you have hydrogen less and carbon more. So the contribution of negative and positive charge will be almost equal or more than that here compared to this. So dipole inducement of dipole is easier in this case compared to this case. So therefore normally the boiling point will be higher for cyclopentane compared to normal pentane. I hope you found the answer useful. Thank you.